Hello, good morning. So in continuation of the lecture on dissolving metal reductions, so today I'm giving a lecture on another type of dissolving metal reductions. So we know that dissolving metal reductions can be classified to three main types of reductions. Okay, so we have discussed first one is reduction metal with metal and liquid ammonia, with metal and liquid ammonia. That is the first type. And second type is reduction with acid, metal and acid. Okay, reduction with metal and acid. And third one is reduction with reduction with metal and alcohol, metal and alcohol. So in the last class, so we have discussed about the reduction with metal and liquid ammonia. This one we have discussed. So dissolving metal reductions can be classified, broadly classified into three types. One is reduction with metal and liquid ammonia, another one is reduction with metal and acid, and third one is reduction with metal and alcohol. First one we have discussed in the last class. So today I will give lecture on reduction with metal and acid. Okay, so reduction with metal and acid. Okay, this one will. So this is generally very common reactions, which is commonly known as, it is also known as Clemenson's reactions. Clemenson reduction or reaction. Okay. So here carbonyl groups are reduced. Carbonyl groups are reduced. So here carbonyl groups are reduced. Carbonyl groups are reduced. So here aldehydes, metal, in presence of acid. So they will be reduced to methyl groups. Okay, this one is compared oxygen removed compared to RCH3. Similarly, ketones are reduced. Same case, you can say do metal and acid, and they can reduce to CH2. So in the case of aldehydes, they are reduced to methyl. In the case of ketones, they are reduced to methylene. Okay, so this is generally Clemenson reductions. So in Clemenson reductions, metals are generally use zinc and ICl, but zinc is used in the form of amalgam, that is in presence of mercury. So I will give you one. So we use the mercury with zinc. Okay, because zinc, when zinc react with ICl, so you got zinc chloride and this hydrogen is evolved. Okay, it is a hydrogen. So due to this presence of this presence of ICl with the zinc, we got hydrogen is evolved. To check the evolution of hydrogen gas in the reactions, so zinc is always used with mercury. Okay, you can say amalgamated zinc. So you use zinc, metal is used in the form of amalgam, zinc mercury amalgam. So here to check the evolution of hydrogen, zinc in the form of this in amalgamated form is used. So I'll give some examples here. Say for example, C6H5 CO carbonyl group and CH2 CO2H acid group. Okay, here zinc, mercury, amalgamated zinc and WiCl, and then you can have toluene or some xylene, toluene or some toluene or xylene with ether. Okay, so here only carbonyl group is reduced. So it comes to CH2. You can have C6H5. So there are 1, 2, 3. You can write 3 CH2, 3 CH2 group B3, and then acid is there SCO twice. Okay. So in this way, one example is that this group, this ketone, is reduced to CH2 group. Another example say in C6H13 cyclohexyl group and carbonyl group in CH3. So here also same case, zinc, mercury, in presence of cell. So acetic acid can be used, and water, heat reflux. Okay, you can give. So here this carbonyl group is reduced to CH2, cyclohexyl group, CH2, CH3. So I will give another example in cycle systems. I will give another examples. So here another examples I will give. Okay. So cycle one. So this one OCH3 and is benzene ring, and then you can have the aldehyde group, that was a aldehyde group, and let's say one OS group. Okay, so you use zinc, mercury, and HCl. Then you can use acetic acid, or even here so you can use some proton donor or ethanol, water, and reflux. So here also these groups, others are not intact, are not reduced. Only this part is this carbonyl group is reduced. So here is aldehyde. So you can have aldehyde should reduced to methyl group. Okay, or here one intact, so here reduced to CH3. So what I want to say that in Clemmensen reductions, aldehydes are reduced to methyl, and then ketones are reduced to methyl group. Another example is that even zinc dust can also be used if with hydrogen gas, hydrochloric gas is produced. Zinc dust can be used also. So another experimental use in Clemmensen reductions, a solution of ketone, say for example, this big ketone, steroid, say like this. Here like this steroids. This fiber body C8 H17, and this carbonyl group here. Okay, this will be reduced. So here zinc dust is used, zinc dust, and the HCl hydrochloride, hydrogen chloride gas in the form of gas. So this bubble to the gas is double in acetic anhydride reactions. In acetic anhydride solvent. Okay. So here this is reduced, others are intact. So the product will be carbonyl group will be reduced. So here rest you can write okay this one. So here this comes to CH2, the carbonyl group reduced to. So what I say, in Clemmensen reaction can be modified. Instead of using the zinc amalgam, you can use zinc dust with a solution of zinc ketone in acetic anhydride, or ether also, acetic anhydride, or you can say ether also. So here this compound ketone is dissolved in the acetic anhydride or ether. Then zinc dust is put inside this, and then hydrogen chloride gas is bubble. Okay, so you got this one. So here another one. So how this is for mechanism? Let's see the mechanism of the reaction with metal and acid. Let's see the mechanism of the reaction. Okay, the mechanism. So mechanism of the reaction with metal and acid. So let's have first one. We can have this carbonyl group. Okay, this one is another one. First is HCl acid. So you can have this way HCl, and then this zinc and mercury amalgam. Okay. So in presence of HCl acid, first is protonated. Protonation takes place, abstract of the proton from the acid, so it gives like this. Okay, half prime. Then this loss of this can be lost like this, or you can have this way R COOH R prime. Okay, this is coming like this. Okay, so you have positive charge here. Then this attacked by zinc. Zinc has 2 electrons. They have 2 electrons. So first transfer here, 1 electron transfer. So it forms OH here. 1 electron transfer here. So it gives a radical is formed. A radical is formed, and these radicals, again, it is a loss of this one. You will get another zinc with another zinc metal. So you have zinc has 2 lots. So another attack here. So it gives zinc. I write down here. Okay, zinc. One goes, another goes like this. So you get an intermediate OH, zinc R prime. Okay, so zinc have 1 electron here. So now, in presence of proton donor, so I shell of positive charge is here. So now loss this one is positive, as minus is water is lost. Okay, so water is lost. So you got this intermediate cation plus zinc. Okay, so this can be this one. I'll write okay. This one, another one. This can write. Okay, go. So this again zinc can be write this way also. This can be written like R, C, R prime, and zinc positive charge. This is shifting, so you can have positive charge here. So it goes this way, this way. So transfer here, electron transfer here, and it comes. So now you can write this way. So now this one, in presence of another, this one, zinc, metal, zinc. So you can have another one. So you can convert it to, this radical is converted to anion. Okay, anion. So you have zinc here, zinc positive. So this anion takes the protons, from the proton or from the acid. I shell proton. So you have, so pick up the proton. So you can have product this intermediate RCH R prime zinc. Then again you can have another proton pick up. So like this. So you have this this bond pick up this, so become zinc becomes, another hydrogen is pick up. So it becomes CH2, then R prime plus zinc becomes lost one. So it comes zinc 2 plus. Okay, 2 plus. So we lost this one. So 2 plus. So generally it gives us zinc chloride. Okay. So this is the overall mechanism of the reduction with metal and acid. So generally carbonyl groups are reduced by this metal. So I'm repeating this one again. This mechanism. So first, this ketone is protonated, and then my zinc transfer. So you give the and a radical is got, and this shifted this one. You can get zinc like this. Then another electron is coming to get the carbon ion. This carbon ion pick up the proton. So you got this one another intermediate. Then again pick up proton. So it gives like this. So pick up the C. So here link with the hydrogen. So it becomes CH2, and zinc becomes lost. So it becomes 2 positive. So it can as a chloride. This one died from ICl. So 2 types of chloride loss here. Cl. Okay. So you can have ICl like this. So you can do CiCl, 2 chloride. So this is about the mechanism, and so we have this is very next time I will give a lecture on reaction with methane and alcohol. So this is for today. Let's all have this one. Okay.